Briony Horgan, Professor of Planetary Science at Purdue University. So the geology of Mars appears to be telling us that Mars was a pretty wet place. We see rivers cutting through the terrain. We've landed 2 different rovers so far in ancient lake beds. There might have even been oceans, we're not sure. However, this gets confusing because when climate modelers try to model using computers what the ancient climate of Mars might have looked like, they actually have a very, very hard time making it anything other than just cold and icy. Because at that time, billions of years ago, the sun was actually much fainter, putting out less light and heat, and so all of the planets in the solar system were colder. So Mars, being farther from the sun than the Earth is, actually was a pretty cold place in that period of time. So how do you explain the fact that we see the evidence for running water, but that it's really hard to create a climate on ancient Mars that was warm enough to have liquid water? Today, Mars is a dry, barren planet. It has a very thin atmosphere. Liquid water isn't stable on the surface. So if we're seeing evidence that there was liquid water, maybe even a warm climate that existed, how is that possible? So something about Mars must have changed, right? And we think what changed was the atmosphere, that billions of years ago, Mars had a much, much thicker atmosphere, maybe even thicker than the Earth's is today, that could have supported that climate. But that over time, it lost that atmosphere due to giant impacts stripping away, and just the fact that Mars is a smaller planet and can't hold on to its atmosphere as well as Earth does. So it's really telling us about really long-term climate change on a planet, but due to a totally different cause than here on Earth. This is important because Mars is one of our best bets still for understanding where life might exist beyond Earth. And we'd really like to understand where life might have first started billions and billions of years ago. And Mars is basically the only planet we have access to right now that preserves a record from that period of time in the solar system, a time capsule, really from the first billion years of solar system history. On Earth, the rocks from that first billion years are all gone. So on Mars, we have this wonderful record telling us how terrestrial Earth-like planets might have evolved over time. And so in our group, we're trying to understand specifically what the climate of early terrestrial worlds looks like. So the tact we're taking to try to understand what exactly is going on with the climate of ancient Mars is to look at a totally different kind of record of water on ancient Mars. So instead of just looking at water as it carved through the landscape, we're looking at the rocks that were altered by that water as it flowed across the surface. So what we see are all these locations on ancient Mars, hundreds of them across the most ancient parts of Mars, that have been rock totally altered to clay minerals like you would find in the soil in your backyard. And what's exciting is that it's not just a little bit of clay. We find that it's tens to hundreds of meters of deep clay-rich rocks. On Earth, the way that you form that is by rain falling on a surface and leaching it very deeply, usually under a pretty hot and warm and wet climate, to form soils that deep. You know, the soil in your backyard is maybe a few feet deep. We're talking about things that are orders of magnitude deeper than that. And so that seems to be implying that ancient Mars may have actually had persistent warm climates for some period of time. One of the things we're really excited about this research for is because we think we'll be able to test some of these ideas when we actually get samples back from Mars. So the Mars 2020 rover right now is collecting samples on the surface of Mars, and the Mars Sample Return Program is going to return those samples to Earth in the next decade. And so we're really excited to be able to get samples from some of these most ancient periods of Martian history that'll have mineral records in them, maybe even trapped little droplets of water that can tell us about what the climate might have actually been like on ancient Mars. So this research is providing really great context for those samples when they come back. We're using data from satellites in orbit around Mars to investigate these ancient soils that are all over the most ancient parts of the planet, to look at first how deep are they, how thick are they, so really carefully measuring how thick the exposed clay sequences are, and then also looking at their mineralogy, because that can also tell us a lot about the chemistry of those ancient surface environments. Was it an ancient swamp sitting on the surface, or was it a nice, well-drained hillside? And that'll help us understand what kinds of microbes could have lived in those ancient ecosystems, right? Because we can look at what chemicals were available for the microbes to eat. We can look at how much water there was on the surface, and that'll tell us about weather, climate, and all of that. So we're really excited to see where this research goes.